Astronomy isn't just the study of the stars. It's been a fascination to mankind for thousands and thousands of years. Starting with Mesopotamians around 500 BC, the ancient civilization built ziggurats, pyramid-like towers, they used as observations to study the stars. They developed a workable model of the relationship of the Earth to the sun, moon, planets, and stars, and were the very first astronomers to make long-term written records of their discoveries, although they were mostly lost or destroyed over the past several thousand years. Also, the Mesopotamians were the first astronomers to come up with the 12 zodiac signs: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces.
The Egyptians also made many important discoveries in astronomy, about 500 BC. As far as we know, the Egyptians developed and used astronomy for particular purposes, such as developing a calendar to be used for predicting the Nile flood, and in aligning temples and in monuments. For example, the pyramids' corners are in the directions of north, east, south, and west.
Moving forward is the mysterious Stonehenge. The Stonehenge was thought to be built around 2000 BC, taking about 1,500 years to build. It's believed that the Stonehenge was an ancient astronomy observatory. Theories are that it was built to predict eclipses and it was used as a calendar.
In the 13th century BC, the Chinese have made and recorded observations of eclipses: 900 solar eclipses, 600 lunar eclipses, during a period of 2,600 years. They also documented guest stars, in other words, exploding stars. As well, they recorded meteor showers.
Thales was another important astronomer that lived from 624 to 547 BC. Thales was famous for predicting an entire solar eclipse. At the time, only lunar eclipses could be predicted.
In 582 to 500 BC, Pythagoras made a solar system model, assuming that the celestial bodies moved in a circular path, introducing the idea of the celestial bodies are being spherical, including the Earth.
Babylonians about 500 BC found regularities and patterns in the motion of the moon and the planets. They found that each planet has a syndonic period, the time needed for the planet to go from one spot to another and back to its original position. About 2,700 years ago, the Babylonians were also able to predict some lunar eclipses.
Next, another one of the most important astronomers was Aristotle, 384 to 322 BC. Aristotle was a student of Plato and also held the Pythagorean view that the celestial objects are spheres. He also believed and taught that all celestial motions must be circular, and he argued that Earth must be motionless at the center of the universe.
Aristarchus, about 310 to 230 BC, applied geometry to the study of astronomy. He showed it's possible to use geometry to find the distance to the moon and relative distances and sizes of the sun and moon. He used methods using shadow sizes, diameter, and time to estimate the sizes of celestial objects.
Eratosthenes, 276 to 175 BC, used geometry to calculate the size of the Earth. He used a relationship between latitude and altitude of the midday sun to find the difference in latitude between Sinai and Alexandria. He found Earth is 15 times as large as the distance between the two, a surprisingly accurate result for his time.
Hipparchus in 134 BC discovered a new star, made the earliest systematic catalog for about 850 of the brightest stars, and discovered precession, the slow movement of celestial poles with respect to the stars that causes coordinates of the stars to change with time.
Mayans and Mesoamericans. In Mexico and Guatemala between about 1,000 and 2,000 years ago, they had a calendar that kept track of the sun, moon, and rising and setting of Venus. They built many monuments buildings that were aligned with the position of the sunrise and sunset at the equinox and solstices.
Ptolemy worked in Alexandria from about AD 127 to 151. His major accomplishment was the completion of a system that could accurately account for the motions of planets using a combination of regular circular motions.
Arabs and Muslims. 7th to 15th century, improved many observation techniques and made careful observations. They also improved ways in which planetary positions were calculated. They translated many works of ancient astronomers, including Ptolemy, from Greek to Arab.
Nicholas Copernicus, from 1473 to 1543, proposed the first fully developed heliocentric model of the solar system. He agreed with Plato's theory of the sun being at the center of the universe and that the earth rotates around it.
Brahe, 1546 to 1601. Brahe came up with the first evidence to support Copernicus' theory. At 26, he wrote a book over his observations of an extremely bright star, or nova. His observations were a benchmark against which astronomical theories could be tested.
Galileo Galilei, 1564 to 1642, used his telescope to make important observations of the stars, sun, moon, and planets. He discovered that when looking through the telescope, a lot of stars were actually a lot smaller than they were originally estimated to be after Brahe.
Kepler, 1571 to 1630. Kepler solved the problem of planetary motion. First law of planetary motion states that the planet moves on an elliptic orbit with the sun at one focus. Second law states that a planet moves so that an imaginary line connecting the planet to the sun.
Isaac Newton, from 1643 to 1727, pulled the scattered ideas and discoveries about motion and synthesized the laws of motion and gravity. Newton's three laws are the law of inertia, law of force, and the law of action and reaction.
Edmund Halley, 1656 to 1742, is best known for computing the orbit of the Halley's Comet, recorded the celestial longitude and latitude of 341 stars, and observed Mercury. Like Newton, Halley tried to develop a mechanical explanation for planetary motion.
Albert Einstein, from 1879 to 1955, revised Newton's laws of gravity to make them more accurate. He developed the theory of relativity, and his observations explained some of the major problems in the physics and astronomy of his time. He also discovered the existence of black holes.
Niels Bohr, 1885 to 1962. He made numerous contributions to our understanding of the structure of properties of atoms. He was a Nobel Prize winner for discoveries about atoms.
Wolfgang Pauli, 1900-1958, worked with Bohr and Heisenberg. Pauli's exclusion principle limits the number of particles of a given kind that can be put into a cubic meter of space.
Werner Heisenberg, 1901 to 1976, developed new theories in quantum mechanics about the behavior of electrons that developed uncertainty principles. Explains the possibility of knowing exactly where something is and how fast it's moving. Werner Heisenberg, 1901 to 1976, developed new theories in quantum mechanics about the behavior of electrons. He developed the uncertainty principle that explains the possibility of knowing exactly where something is and how fast it's moving, mainly applied to electrons.
Edwin Hubble, 1889 to 1953. His research helped prove that the universe is expanding and created a classification system for galaxies that proved that other galaxies existed outside the Milky Way. NASA's Hubble telescope was named after him for his discoveries.
George Lemaitre, 1894 to 1966. He created the first definite formulation of the idea of an expanding universe, what was to become known as the Big Bang Theory. He called the Big Bang Theory the hypothesis of the primordial atom.
Robert Oppenheimer, 1904 to 1967, also known as the father of the atomic bomb, led the Manhattan Project. He developed the first nuclear weapon in World War I and made important contributions to the modern theory of neutron stars and black holes. Fred Hoyle, 1915 to 2001, rejected the idea of the Big Bang Theory. He developed the theory of stellar nucleosynthesis that states stars die and create new elements after they've used up abundant amounts of certain elements. He also supported panspermia theory that states all life on Earth must have involved cells which came from space.
Armstrong and Aldrin. Neil Armstrong, 1930 to 2012, and Buzz Aldrin, 1932 to present day, were the first humans on the moon. On the Apollo 11 spaceflight, on July 20th, 1969, Armstrong was the first person to step on the lunar surface, spending about 2.5 hours outside the spacecraft. Aldrin slightly less. Together, they collected about 47.5 pounds of lunar material for their return to Earth.